Swayam Prabha. Digital India. Educated India.
An infinite wall. Okay, you have an infinite wall. You are somewhere against the wall. Let's say you are here. This is where you are here. The P is a person. This is where you are along the infinite wall. Okay, there is a magic door. Okay, there is a magic door, and that door will become visible only when you go right in front of that. Otherwise, it won't be visible. Let us assume that it is somewhere here. You don't know where it is, right? You just don't know where it is. Let us assume that. So, unless you come to this point, this won't be visible. It's a magic door. Okay? The other end, as I said, the magic door, Bill Gates is waiting to give you $1 million. So, you have to figure out and then go to that gate. That's the problem. Now, some mathematical parameters. We are going to assume that it is n steps away from where you are. You don't know that n. You have no idea. I am simply introducing a mathematical parameter n. It is n steps away from where you are. You do not know whether it is to your left or to your right. Nothing is known. Even n is not known. Well, if n is known, let us say it is 200 steps away, what is that you would do? You go in one direction 200. If it is not there, you come to the point where you are and again go 200 on this side. You will find it. So, 200 this way, 400 this way in 600 steps. If it is n in general, n one way, again 2n the other way, in 3n steps, you will figure out where the gate is. If n is known, right? But n is not known. You do not know what that, how many steps it is away, you do not know. N is a presentation for that actual number. Okay? You have to, this is used to measure how many steps you are taking in a particular method. Okay? So, that is what n is used for. Now, guys, come up with a way to figure out where the gate is. What can you do now? It's already 3. Shall I go ahead for some more time? Is it okay? Huh? It's okay to go through because just now I have started interaction. Okay, thank you. So, they are just engaging. Yes. Yeah, go ahead, tell me. Very good. You have got, okay, this is one method. Any other method? Yeah. Assume? What is your assumption on n? Right. That is the same as his method. Okay. Any other one? No. Any method. I want first a method to solve the problem. Yes, you have said already. You are going. No, we will figure out one idea at a time. Yeah. No. See, I don't have any idea of n. No clue on n. Nothing you should assume about n. Yeah, we will come down to you later. Yeah, behind. Yes. Yeah. No, not 2. Only 1. Currently, the problem is only one person. Yeah, if there are two, then they can go away, and then if what happens if one goes outside the range of the signal, he can't call the other guy saying that, hey, I have found out, and this guy will keep on going, right? Fortunately, there are no two. There is only one guy around. He has to figure out. So it is also there put in several ways. You are in a junction, right? There is a main highway in a desert. You are in a junction. Suddenly there is a dust storm, blinding dust storm. There is a shelter, but you don't know whether it is to the left or to the right. Okay? Same problem. How will you reach your shelter as early as possible? But first of all, you must have an idea on how to go, how to reach. How many of you are thinking incrementally, first of all? When we say a paradigm, when we say that this is what incrementally means, little by little. So the suggestion, there are two suggestions, both of them are following the incremental idea. Sweep 1 and let us assume that this is 0 origin, 1 and minus 1. First sweep this, cover, and then 1 and minus 1. Then come back to origin, then 2 and minus 2. Then 3 and minus 3. You don't know whether it is to the left or to the right. So you have to keep going this way, and at some point, whatever is that n, in that nth stage, either to the left or to the right, you are going to figure out where it is. Okay? So, this is one method. What is the labor component in this method? How many steps are involved in this method? This is called analysis of algorithm. By analysis, labor component you estimate. That is because if you have two methods, how do I know which one is better? Earlier we have clearly shown, one is 20 factorial, another 80, very clearly. That clarity you will get. Now let's focus on the analysis. Analysis I am not done yet. Right? I am going to ask you a question on analysis. You try to answer that first, and then we go for a different method. Right now focus on this method, the analysis part of it. Okay? Hold your thoughts. I am going to come to you. Every opinion will be sought. I am not going to leave out anyone. Okay? Just because right now we are on a particular mission, there are many people in the class who might not have yet got the grasp of things. They will be slowly following, right? Therefore, I need to make sure that everybody understands. So, I will come to the speed thinkers a little later. First, let me do this. Okay? What is the number of steps involved? How many steps? Right? N? N into? N into n plus 1 by 2. I don't know whether that is correct. See, yeah, it increases by multiples of 4. No, sir. You go 1 here, you come to minus 1, 1 plus 2 times 1 plus 1 to come to origin. Then 2 plus 2 times 2 plus 2. 3 plus 2 times 3 plus 3. The 3, 2 times 3 and come back to origin. Every time you come back to origin and then sweep for minus n and plus n. So this you go up to n minus 1 plus 2 times n minus 1 plus n minus 1. So this is then with respect to n, let us assume the worst case. You go n in one direction, you didn't find it. You go n in another direction, you found it. So the last step only will be 3n, because there you are not going to come back to origin. You have found out the gate. Therefore, the last one will be 3n. The other steps will be like this. That is 4 times 1 plus 2 plus n minus 1, which is n times n minus 1 by 2 plus times 4 plus 3n. This will be 2, and therefore this is 2n square minus 2n plus 3n. Therefore, this is 2n square plus n. Therefore, the first lesson I want to all of you follow is correctness. Don't have a rush of a blood and then simply say an answer. Mathematics is for rigor, perfection, exactness. You cannot simply put something in your head and then roughly and vaguely think that this is how it is. Don't do that. That if you do that, the very advantage offered by mathematics you are going to lose. Why mathematics is there for you? To make sure everything is precise, exact, well defined. If you don't apply math properly, you are going to get wrong answers. So mathematics is, what is mathematics? Mathematics is knowledge and attitude. Remember that. Exactness. Mathematics does not come with a flash of things and hasty guesses and other things. It requires an attitude. Okay? Unfortunately, these are some of the things that we are missing in the school. People, they go through the drill in a very mechanical way and then they forget that the very purpose of mathematics. Mathematics learning is to be done in a different way. We have to see the logic. We have to see the purpose. Here there is a logic, there is a method that I want to compute. Why don't we take a sheet of paper and write like this and derive this? Why this was not taught? This is what is to be taught. Go exactly, represent your thoughts in symbols. Go through step by step and do carefully the math. Then you will get the advantage of mathematics. It will empower you. Otherwise, it will laugh at you because your answer is going to be wrong. Okay? It's not for marks. It's for representing a thought and logic. Therefore, my message is that do like this for your next any improvement. For example, if n is 100 steps away, if n is 100, this is going to take 100 times 100, 10,000, 20,100 steps. It is actually 100 steps away, but this method is taking 20,100 steps to figure out where the gate is. You are doing a lot of wandering. Now the next question, can you make it more efficient? Okay. Now, I will again reach you and then collect your improved ideas or whatever it is. Okay. What's your idea? I fully agree with you. Find out the labor component. That's what you have to do. You have to prove me that this is better than 2n square plus n. Whatever is your method, count the number of steps until you reach and then tell me you are going to have only arithmetic progression and nothing more than that in this process, which the formula you know very well. Figure out and then tell me. Yeah. Take time. Huh? Huh? I'm somehow not able to get you at all.
Sufficient to just do 3 times n is what he thought.
3 times.
That's his question.
You don't know n. You have no idea what n is. That is the reason why. So, thinking that the next step is, there is a gate, because only in front of that you can see. You will further go. And then thinking that next it is there, you will go. You don't know n. In fact, you don't even know that n is on this side. So, thinking that next step you will figure out the gate, you may walk. Remember, this is an infinite wall. So, your algorithm may not even terminate. That is the reason why go in one direction, figure out whether it is there. If not, you come back, doesn't work, because in the direction in which you go, the gate may not be there at all. Thinking that you would figure out in the next one, you will keep on going it, and you know that's not going to work. Right? Yeah, your suggestion. Which one? No, whatever, no, don't worry about his method. Whatever you have heard vaguely, you refine it, come up with your own way of figuring out where the gate is and calculate the labor component of it. You do whatever the method, because our business here is, our motivation here is to find a better method. Immediately after getting a method, we have to know whether it is a better method or not. How do I know whether it is a better method unless I count the number of steps? I already have one method which takes 2n square plus n steps. This much is clear. This is where the, yeah, what's, huh?
Then we go to -1, but instead of going to 2 again, we take an additional step towards -2, and then we go to 2 this side.
I appreciate your idea. Figure out the labor.
Yes, that's
Not less than. If it is less only by 10, I will not accept that as a great idea, isn't it? It should be significantly less. Is it significantly less? How much? No, you keep improving. I am not going to say, this is a creative exercise. You do your best to give the best of the improvements. Whatever comes to your mind, you bring it. Because this is a problem that has got no single solution. There are several clever ways, and you be creative and then go ahead and then be creative. Try your own self. That's why I have taken an open-ended a question which is easy to understand. Multiple solutions are there and each one can try, and this doesn't require any big mathematical background or anything. You grasp immediately. I pulled out one case study for this discussion only. Of course, this is taught in computer science course in a different flavor. I am presenting to you in a completely different way, more as a puzzle. That is okay. Even if n is at 50,000, you are going to go in incremental fashion, but in thousands. Find out what advantage it offers. There are several interesting suggestions are coming up. All are good ones. All are good ones. Well, what's your name? This the girl next to you. Kavya. Okay. Kavya's suggestion is in fact very good one. So it's only that she is struggling to figure out the complexity. Isn't it? You have difficulty in finding out how many steps are there. Very easy. No. For the method you have found out, find out how many steps are involved, compare that with 2n square and tell me whether it is better or poor idea. You may have an idea, but after calculating the steps, if it takes 3n square plus 2n, there is a method of that many labor. That's a poorer algorithm. Why? When I have 2n square step method, why do I want a 3n square step method? I will ignore that method. I will look for something which is better than this. Yeah, your suggestion. No, definitely that's an improvement. What is your method? But how will you get 2n square plus 1? There you might have made somewhere some mistake. No, you don't know whether it is on this side or on this side. So after that you may have to come to the next even number. No, the last step can never be 1. Last step can never be 1. Whichever the previous stage, okay, for the last stage, you always assume the worst possibility that it is at the other end, wherever you are. So don't assume that in one step you would do, you must go to the other one. So when you do that, it becomes 2n kind of a thing. So it will become more than this method. It will become slightly more than this one. It's good, very good. No consultation, please. Why are you talking with your friends and neighbors? I really don't understand here. It's a creative challenge for you. You individually do it. Don't consult with your neighbors. Yeah, tell me.
So then, the total number of the gate is n steps away from us, right? So we can assume n is equal to m times k. Where
No.
Sir, where m is the number of increments.
No. You can't assume anything about n.
No, but I'm just asking. So like, I'm assuming n is equal to m times k because so m is the.
No, that is where the whole thing becomes wrong, because you cannot assume anything about anything about n. If you are taking a steps in one unit, right, then your assumption may work for that case, and for other cases it may not work. And basically, we are not allowed to assume anything about n. So think of alternate ways. Don't assume that n equal to ka for any a or something like that. 3 people are converging on one method. I told you not to do that. You take your own sheet of paper and then work. Kavya, do you need assistance for an arithmetic progression sum? Then what's the problem here? Why do you go talking with your friends? Be on your own. I want people to be on your own. Next time when you have, please give me a room that has got 60 different tables. I want to put everyone on one isolated table and check whether they are able to think or not. Looks like without consulting they are not able to think. Immediately they want one. I think the same habit continues. You ask anything, ChatGPT, right? So, no. You are not going to become thinkers. You will become inkers. Yeah. Huh? N square plus n step. Yeah, what is your method?
I go in some direction, so I go from 0 to 1.
Right.
That's the concept. Then I go from 1 to
Minus
minus 2.
2. Oh.
Minus 2 to 3. So if we continue.
Same thing. That's what Kavya also has said. Yeah.
I do for instance and compare it to 0.
That's one method. Yeah. What's your 4 into n minus 1? Totally wrong. There is no way you can do that way. No. Yeah. No, it can't be 4n and all. There is no way. You are making some mistake somewhere. Any arithmetic progression that has got n steps will have n square-ish term, no? No, it is not 4n. Yeah. Please go ahead. Don't think. Give me a proof. Don't work on your head and then roughly say that n square. I told you that is not the way to use math. Be rigorous and then tell me exactly what is the expression. I want to compare that with 2n square plus n. And then determine whether that method is a stupid method or a equally same efficiency or a smarter way. I have to conclude. People come up with various ideas. Whether that idea is a good one or not, how do I judge? You know the famous quotation, Kelvin, you don't understand what you cannot measure. Right? Beautiful quotation. So you don't understand what heat is and what coldness is unless you have a number or a measure associated with it. Great. Scientists have said various things. Unless you measure, how will you understand whether your method is better than this? I have told you a method, computed it, and shown a way to do it. This is exactly what you have to do for your method without consulting your neighbors. That's all is the only constraint. And without using ChatGPT and other things. So let us take Kavya's method. Okay. So because we have to save time, it's already 3:30. So her method is, no, let's move on. More or less the same method with the minor variation, but so you go 1 and then 2 minus 1. 1 to minus 1. This is 2 times 1. Then you go to minus 2. Then you go to plus 2. Another 1 plus 2 times 2. From 2 you go to 3 and then to minus 3. 2 to 3, 1 plus 2 times 3. So this you will do 2 times n minus 1. So you are at n minus 1. So after that, you go one step to n. If it is not there, you go to the other 2 times n. So this is n plus 2 times n into n plus 1 by 2. That goes. So it is n square plus 2n. So whatever Kavya said has n square. Why can't you do this? Why? I will ask them not to give you certificate. That girl is disqualified. Huh? Note down that, please. Just kidding. No, but this is what is there in this. If you focus on your method and then exactly do the calculation, you are getting the answer. It is such a simple one, n square plus 2n. Why are you saying 4n minus 1, this, that, and other expressions and complicated? Very simple thinking. And once the thinking is translated, this is where the power of mathematics is to be used. Think, focus, stay on your desk. Don't converse with your friends. Remain focused. Without concentration, you are not going to win in mathematics. Okay? This is what you should do. And when you do that, you get this. Let's say when n equal to 100, 10,200. This is 20,000. This is 10,000. 20,100, 10,200. Half. You have cut down. One smart way. A small move has significantly saved your labor. Go smarter. Now, what is another smarter way? Less than n square plus 2n. Now you guys have to figure out. Okay? So whatever is the method, first make sure that your method is analyzed by you and then tell me the answer. Don't simply say something and then I think this is better than that and stuffs like that. We have crossed that stage. Those things you can say half an hour back. Now you have seen 2 examples, 2 ways in which a method is to be understood, represented, analyzed. Now you have to be serious. Okay? Come up with any method and then what's your method and what is the complexity? N square plus 5n by 2 is not really attractive, no? Because that is 2.5 n. Oh, yeah, n square plus 5n whole divided by 2. Oh, I thought n square plus 5n by 2, that by 2 I thought was associated with 5n. No, it is n square 5n by 2. This may not even be an integer. How did you get this number of steps? For example, if n is odd, the whole thing is odd. The odd also this is right. This is odd and even and then yeah, this is okay. But is the analysis correct? Ah.
First I move a step to the right, and one more step to the right, and 3 steps to the left, and another step to the left, and whole I repeated the process. So
what is the geometric, arithmetic progression you are getting? First, what was the first term? First you went where?
So n times 1.
No. First, what is your first? 0 to 1. Then
1 to 2.
Then 1 to 2. Another 1. 2 to minus 1. That is another phase, right? 2 to minus 1 will take 3. 2 to minus 1 will take 3.
And minus 1 to minus 2.
Then that is another plus 1. Then
I repeated this process.
no, this is the minus 3 you went, no?
Yeah.
From minus 3 you went to
Minus 3 to 4.
minus 3 to 4. Minus 3 to 4 will be 7. I think this is where you might have made a mistake. Minus 3 to 4 it will be 7.
Minus 3 to 3.
Then there is no uniformity in your method.
I got 1 plus 1 till n times and 3.
No. First you freeze your method. For the method you must come out with the analysis. First, make sure that your steps are logically correct. Go through your locus points, right? I'm starting from here, I'm visiting this on the right, this on the left, then this on the right and this on the left. Make sure that that logic is correct. Then for each step that you have done, write down to the right hand side the corresponding expression and then sum it up. you should get it. Same thing that I have done. This is a good illustration of how to understand a method and how to analyze it. Both of them has been done reasonably well here. This will help you in, clarify your thought. Yes.
Sir, I have a question. Is it compulsory to pass through each number at least once?
Of course, if you miss something, what if the gate is there? You have to walk through. But while walking through, right, if you find a gate, you are allowed to stop there.
As I feel, why going in circles one?
No, I thought that we have to in case go that.
No. You can go through steps of 2. Anyway, if you see the gate in between, you can see the wandering is reduced. See, it's from 0, you can go to 1 and see whether it is there, and you can go to 2 and whether it is there. If not, you can again trace back. Yeah. What is the expression you got? 2n into n by k. If it is 1, does it give 2n square plus n? So what he is saying is, instead of 2,000, he has taken a liberal number, but in general, some 5, 10, anything you can imagine, just for sake of comfortable thinking, sweep 10 in one direction, go to the other end and sweep 10. In between, if you see, you can stop, but let us assume that you are going through this several number of stages. Obviously, you will go through n by k stages of this. In the last sweep, you are going to hit on n. That has to be analyzed. How many of you can analyze this? Again, only arithmetic progression. Yes? 2n square. That will be 2n square. That's why when he got n square plus 5n by 2, I was a little skeptical about it. So be careful. Yeah, your idea? No. N square minus n plus 1 will be, it might not be possible. You might have made some minor error somewhere. The sum of that sequence. No, what was your method? What is the, first what do you do? You go 1, then minus 2. Let us write down in the next step. From 1 to minus 2, it will be 3. Then plus 3. Yeah, that's what, plus 3. This is 1, then to minus 2, then to plus 3. From minus 2 to plus 3, it will be 5. Minus 4. That will be 7, right? No. You go up to n minus 1. You go up to n minus 1 in this way. For n, you assume the worst case. That is, you go 1 in this side, that n is not there, and the other n you go to the other. So that will be again n plus 1 is what will be finally added. Or n plus 1 or from n minus 1 to n. Only 2n minus 1 will be added, right? No. In this one, see, when you go to, this is 1, this is -2, this is 3, this is -4, right? So this is how you are going. Let us assume that whatever it is up to n-1. When you do like this, it is going to be 2 times n-1 minus 1, because that is the pattern you are seeing here. Okay. No, this is same 3, 5, 7, right? This is what you are going to get. And after coming to n-1, what is that you are going to do? You are going to go to n on this side. Assume that it is not there. You have to go to the other side. Therefore, from n-1 to n, another 2n-1, and from whatever is that n, it is not there, to the other side, another 2n, and this is what is the sum. This is 2n-3. This is 2n-3, and this is 2n-1. All right. So this is the sum of first n odd numbers, which you know is n square plus 2n. N square plus 2n. We have n square plus 2n algorithm already. So you have come up with a method which is having the same labor as one of the methods that we have already. This is how we conclude. See, we have to try. It's not that just because a method is different, it has to be more efficient. You may try. The whole point I want to drive is, you have to keep trying. You have to keep discovering methods. You have to find the effectiveness of that method and then compare with the known method. Then take a judgment call, whether it is a better method or same, or is there any improvement. Here we could see the visible improvement. Like this, I want you to improve further. There are several clever ways to improve this further. Several clever ways to improve this further. So I want you to figure out, spend some time, okay, think it over, and then my suggestion is, first you think individually, then collaboratively. Don't sit and collaboratively think. That is not going to help. You are not going to get a different perspective. When you think deeply, and when you miss some point, and when you discuss with your friend, if that friend complements your idea, then both of you will improve. When you sit together and then work, both of you are not going to improve yourself. So the best way to use friends and collaboration is, first build individual strength, so that when two strong people interact, the benefit will be mutual and there will be a further build-up. Therefore, go to your room, individually work, and then choose your friend and then discuss. Feel free to discuss. And it's open world, after all. And why are we having friends? We do learn a lot through peer discussions. So go ahead, but don't lean on somebody. Build on your own the method and then discuss in equal terms. I thought about this way. What did you think about? Like that, when you exchange, you will benefit. So get the maximum mileage out by using your friends, by first building individually your strength and then collaborating with your friends. Okay? There are several ways to improve. Keep thinking about it, and I would probably stop at this point. Okay? So,
You are a surprise to Arvind. I didn't tell you, right?
huh?
I didn't tell Arvind that he is coming. No.
Yeah.
Oh, you knew?
Oh.
Oh, very good. Okay.
Oh.
I used to communicate.
Huh.
That's all. I used to say.
So it's just that I want to have just some fun session with them and give a problem and interact.
You introduced me? Oh, the student introduced me.
Yeah.
Okay.
Her mother was my student. So she did internship and project and all with me, and so
That was
she.
before you were born, I guess.
Yeah. Long time back, when she was undergrad. Yes, Kavya is not going to give up. Huh? That's what I want you to find. That's exactly what I want you to find. So maybe I will tell you a method or a hint and then figure out.
Yeah, I want to more on you missed a wonderful lecture.
Hello.
The point is, he wanted to meet you also.
Yeah.
Wanted to meet you.
Yeah, sure.
So he is going. You are going to be tomorrow's speaker, right? Tomorrow's speaker, yeah. You are going to be. Yeah, he's going to be tomorrow's speaker.
Oh, okay.
Yeah, just meet with him. Okay. I mean, it was coincidental that I called him a few days ago and was talking to him about RSI. He has given lectures, RSI lectures before, maybe a few years ago, I guess.
Yeah.
Several years ago. The only thing is now he has moved to, he was our professor of computer science for almost 40 years and has produced some of the best students all over the world. They are his PhD students who have now settled down everywhere. He has a very strong alumni. Today, if he is asking for something, I think more than what he asked for twice or thrice, whatever he asked for will come to him because his friends, his students have such a phenomenal respect for him. And above all, despite the hard-looking view that he is giving you, he's actually a very soft, nice person. If you talk to him one-to-one, he will sit down and handhold and solve your problem. But he will make you think. What I liked very much about my interaction with him is that I never studied computer science under him, but that's one missing point. But unfortunately, we both seem to have the same age.
Yes.
And we
are
worked out in
contemporaries,
different periods. He has given some lectures, but I'm not able to record his lectures for the NPTEL so far. You have done one or two.
The IITs, they requested me.
They have
and
requested
then,
you to do that. Yeah. You had earlier did one algorithms course, but was
But
very
that is
long.
completely burnt.
No, it was a BTech. It was a BTech lecture. It was
The
completely-
building, ICSR building,
ICSR
when that
building,
was
yeah.
burnt,
It
the
was
whole
very
lecture
unfortunate
was
thing.
lost.
So, one of the best known computer science in the world, and he is, of course, a very famous person for, cryptography, which is the most important field today in a lot of industries and so on. So, it's very nice of him to actually agree to come here on an extremely short notice, like 3 days or 4 days. And please join me in thanking him for having come to this.
Thank you. Thank you very much. I'm honored and then I'm really happy.
Now you want to.
For we teachers, it is a lesson how to teach.
Oh, okay. Thanks. Thank you very much.
In spite.
On behalf of RSIC, I would like to thank Professor Pandurangan for his insightful lecture on the importance of having efficient algorithms, not only in the field of computer science but everywhere in life. We learned the necessity of how thinking by oneself is actually really helpful, which we do not often tend to do so. Once again, thank you for your time and expertise.
Thank you, ma'am. Thanks.